Today, we're going to cover getting started with Azure Open AI Service. Previously, we'd looked at the fundamentals of how a large language model works, how it's trained, how we can consume it and use it as part of a larger AI application. But today, we want to go to the next level of detail and demonstrate how do you actually build generative AI into your own applications using Azure Open AI Service. But first, let's reset and have a look at the fundamentals of how a generative AI actually works inside an application. The key here, the most important thing, is a large language model or a small language model or one of these frontier or foundational models. They are pre-trained. They are just API calls. They're just an API call away. So we often look at generative AI solutions and think, oh, we need to train our model or we need to fine tune a model. That is not correct. We can take one of these models, these pre-trained models, make an API call to it, and we're good to go. So what we're going to have a look at today is how easy it is to get started making those API calls. But we'll first take a look at what does an example API call look like to the Azure OpenAI service or to one of the large language models from OpenAI. In this case, we've got some Python code on the screen here. We've got a chat completions object we're creating. We're passing the messages, which is the my messages there. We are specifying a model, which is GPT-3.5 Turbo, and we're specifying the temperature, and we're passing that to the completions create. Now, what are the messages we're actually passing? So most of these models have what we call a system message, which is it tells the model how to behave, what it is, allows us to set guardrails. It is the guiding instructions for what the model is supposed to do and what it's supposed not to. We are also able to pass user messages. Now, these are messages that the user might have passed or our code might have generated. So in this case, when are my taxes due? And this would be input that has come from the user. It could be much more complicated than that, but this is a very good starting point. We then call that completions create with our messages, and we get back a completion object, which contains the message back from the model. In this case, an assistant message. So the assistant message is what the model has returned based on our system and user input that we provided. And in this case, it reads, "Arr, matey, the due date for your taxes be April 15th in the year after you be earning your booty." Now, I am recording this in New Zealand, and New Zealand taxes are not April the 15th. They're actually a different date, and I can't remember off the top of my head. This is an example of the model making an assumption that I am in the US. This is the tax date for the US. This is one of the things that we are always doing with our large language models when we interact with them, is providing grounding or meta context, which is instruction around the model of what do we actually, what is the country that you're in, or what is the relevant information that help the model give the right answer. Because in this case, it's given me the wrong answer because I'm in a country that is not the US. We'll go a lot more into detail as we start demonstrating some of the prompts that we'll create. But fundamentally, that is how we use an LLM. It is not that difficult. So what is Azure OpenAI Service? So Azure OpenAI Service is a service that's deployed into Azure that makes the large language models, the frontier models that are produced and pre-trained by the company OpenAI, makes them available inside your Azure environment for you to use in your applications. It is backed by all the Azure security, monitoring, compliance, etc. that comes with Azure. So it is the exact same models as OpenAI, the same model weights, the same code, but it is just running inside of Azure and governed by all this, has all these additional governance and Azure practices wrapped around them. But what are some of the things, and we talked about this last time, what are some of the things you can do with these models? Obviously, writing assistant, content creation, this is the basics. Reasoning over unstructured and structured data. So that would be giving the model some information, some data, and saying, explain to me why this might have happened. And summarizing text, feedback, reports, Q&A, looking at sentiment analysis of, say, Twitter feedback or some other information that you're gathering and extracting information from that source information. And finally, of course, chatbot and virtual agent scenarios. So, you might have a website that's selling shoes and you might want a chatbot that helps customers select a pair of shoes. But of course, that's not all that all the large language models provided by OpenAI via the Azure OpenAI service um, make available. There are multimodal, which is being able to take images into the model as input or audio as input and generate different types of output. There's image generation, so you may have used something like DALL-E 3 or another diffusion image generation model like Stable Diffusion or Midjourney. And there's also text to speech and speech to text. So you may have seen some of the amazing demos from OpenAI where they're having an audio conversation with an AI. And all of these are available inside Azure OpenAI service through the same models. So what models specifically, models and features are actually available across in the Azure OpenAI service. Now, this is a continuously evolving, continuously moving. OpenAI releases many new models very frequently, and those models are become available within the Azure OpenAI service quite quickly. They're not always available on day one, so you need to keep an eye on that, but they're usually available very quickly, within a few weeks. But if we look at the different models that are available, there is the ones you've probably experienced one way or another through either Microsoft Copilot or ChatGPT. There's the GPT-4, GPT-4 Turbo, and GPT-3.5 Turbo. Now, GPT-3.5 Turbo was the original model that backed the OpenAI ChatGPT service, but
Hey,
mostly,
Daniel,
yeah.
I have a quick question. What is the turbo means? Like, is it like an extra trained model?
That's a great question. So these model names are not often um, don't necessarily represent a
Ah, right.
specific
Yeah.
behavior. Well, they offer, so GPT-4
Yeah.
was the first model in the GPT-4 family.
Mm,
OpenAI then fine-tuned and tweaked that model to
mm,
improve the performance. And they thought, well, we still have a lot of people using GPT-4. We still need to
mm.
maintain it, but we've now got this faster model, so they've called it GPT-4 Turbo.
For yeah.
So you'll often see the Turbo moniker added to models that are the same base model but have been tuned to improve the performance, and the
Right.
performance is significant.
Yeah.
And the performance is not the capability of the model, so how good it is at answering questions
Mm,
or providing the answers. It's how fast do you get a response,
yeah.
and that might matter to you depending on your application.
Yeah. And the version changes from like 3 to 4 and 4 to 4.0, maybe capability changes.
That is correct. So GPT-3. So if we look back in time, the first models that were publicly available were GPT-2, and that was an open
Mm,
source model available on GitHub. It was quite capable. GPT-3 came out, which was the DaVinci models. They were very capable. They were very good at following instructions. Then GPT-4 came out, and GPT-4 was a next leap forward in capability and ability to
mm,
reason and many different improvements. There's a number of sites you can actually visit, which will show you the comparative
mm.
capability of the different models.
Yeah.
But interestingly enough, that does take us a little to segue, which is within a model family, say GPT-4, there will be multiple versions of that model available. So every 3 months, there might be a new version of the model. So there's GPT-4 1106, there's
Mm,
GPT-4 0125. Those are actually the dates or the month day that those models were released. So you do need to be aware that those models are improved and released. New ones are released over time within the family.
Yeah.
So those are the language models. So they are what we would call text in, text out. You pass in a piece of text and you're going to get text back. Multimodal models, and this is an example of is GPT-4o, GPT-4 Turbo with vision. Those are models where you can pass images and text, or even some, in the case of GPT-4o, you will be able to pass voice, audio, video into it, and you will be able to produce, in some cases, audio, video, and text back, images and text back. So these are what we call multimodal, meaning they can produce and take in different kinds of input. Um, we also have the ability to fine tune some models. So sometimes you might say, I need this model to behave a slightly different way, or perhaps I wanted it to always talk like a pirate. I can't imagine you really would want to do that. There are better ways of doing that, but say you did, you could fine tune the model to behave in a certain way. This is not a this is fine tuning is not a good way to add knowledge to the model. It doesn't reliably add, new information about current events, and it's not a good way to do that sort of thing. This is what we'll talk about in a moment, is in context learning. So fine tuning is available, but it's something you would only do for very certain circumstances, such as changing the behavior or when you want to improve the performance for certain types of output, for example, summarization. The fourth thing is images, and that is the DALL-E 3 model. Now, there was previously the DALL-E 2. We're now up to DALL-E 3, and that is a text-to-image model. So you write some text, and you'll get an image back, or a set of images. And if you've ever used the I think it's the Microsoft Copilot Image Creator, that's the model powering that.
Okay.
And then finally, there's Whisper, which is the transcription and translation, and we call those a text-to-speech or a speech-to-text model. Now, Whisper is a speech to text, meaning you will give it some audio of a conversation or someone speaking, and it will give you text out. Very reliable and robust. There is also a model called the TTS1 and TTS1 HD models, and those are the other way around, and they are text to speech. So you give them some text, and it will generate some audio. The actual the recording of the person speaking. And then finally, underneath all of those models, so these are the different models you also have these different features. So the first feature is on your data. So on your data is where you bring your data to the model, such as, perhaps you've got a whole lot of human resources documentation as PDFs, and you want the model to reason over that without fine tuning. There's a feature built into Azure Open AI service called On Your Data, and we'll show that briefly in a moment. There is also Azure AI Studio. Now, this is the tool or suite of tools that allows you or helps you build and operationalize large language model or copilots at scale in a very reliable, secure way, where you need to continuously evaluate the model performance or your application behavior. So that is something we'll cover in a future session, but Azure AI Studio is also baked on top of the Azure OpenAI service. There is also a feature called Assistance API. Now, this is a set of APIs that sits on top of Azure OpenAI service that allows you to build an assistant out of a large language model. That would be bringing data and relevant information into the model, as well as allowing the model to execute small snippets of code that it might generate. For example, if you were to say, I want you to generate a graph of the performance of my company over the last 6 months, it could write some code to generate that graph. And then the final feature there is provision throughput, which is the ability to say, I would like to uh, pre basically have a chunk of capacity for one of these models assigned to me and only me and be available. And that's something you would do to reduce and ensure you had a very low latency on the response time of these models. Because as we mentioned, the models are just API calls. We make a request, the model processes our request, and it comes back. That data could take a few seconds, and if we want a very consistent response time, we can look at provisioning throughput to ensure we get a consistent low response time. So that's Azure Open AI service in a nutshell, and we are going to show you through all that. But if you've already used Azure before and you're familiar with how it all works, there's a few things that you probably want to know to call out, that we really should call out how they're slightly different if you've used the models on OpenAI as opposed to Azure. So when you deploy Azure OpenAI service, you're actually deploying it into an Azure subscription. It's secured by you, it's controlled by you. Your application data sets will have access to it, or you will configure it to have access to it. It's in your Azure subscription, it's not sitting outside. So that's an important difference. The second point is the models you get in Azure OpenAI are the exact same models as the one you get with OpenAI. Right now, the only difference is that we do Microsoft does wrap some additional content safety and protections around the outside of those models. So where OpenAI might have allowed a risky prompt through, or perhaps they don't, but Microsoft will ensure that all that content safety is wrapped around it and the models are can be used as safely as possible in your particular solution. And those content safety filters can actually be customized. As I mentioned, we can fine tune the models, but you probably don't need to. It is important to remember fine tuning doesn't add new knowledge to the models. It's better to use in context learning, and we'll talk about that soon. Again, the built-in responsible AI, customizable content filters, those are really important. The models are always wrapped in those by default, and you can tweak the settings and make them more detect and be more sensitive to harmful misuse, or you can dial that up and down, but they're always there. Enterprise grade security. So normally when you interact with one of those APIs, one of the APIs to interact with a model, you're using a key, a token to authenticate to that model. That is decent way of securing access to the model, but a better way, which is only available in Azure, is to use Entra ID authentication, and that's where you will go and get an identity token from Entra ID and pass that through to the model, and that's much more secure because they're short-lived and they're able to be tracked and managed. And you also get the ability to put the API endpoint for the model into a private network. So you don't have to do that, but it might be something your organization requires if, say, you are sending more sensitive information to the large language model. I would add that even if you're sending sensitive information to the model, you might want to also consider whether you should send sensitive information to the model. For example, PII. It's always a thing to consider. Do I need that PII sent to the model? The models are safe. Again, they are the same models. They're not the same implementation of the models. There is some things we'll go through in a moment just to talk about how the data is handled sensitively. But the final difference between Azure OpenAI service and OpenAI is that it allows you to integrate into Azure Monitor. So Azure Monitor is the foundational tools across Azure that allows you to monitor both Azure and the applications you run in it. And this is really important because we can then send that information onto security tools like Sentinel. We can build that into our APM, or application performance monitoring. And we can actually build an end-to-end monitoring solution for something using generative AI. And this is really important as we scale up the use of these systems and we have hundreds or thousands or tens of thousands or millions of users using our generative AI solution. We need to be able to monitor it in a very robust, scalable way. So I said the last thing we really need to cover before we jump into some demos is these are the questions I get asked over and over, which I think is worth reiterating here. When you deploy or use a large language model from OpenAI inside the Azure OpenAI service, the following things are we always need to consider. The data that you send to and from, those API requests that you send to and from the model, are not available to other customers. They are not available to OpenAI, and they're not used to improve or train the models in any way, shape, or form. They're not used to improve any Microsoft third party or products or services. They're not used for automatically improving the Azure OpenAI models for use in your resource. Like, for example, it's not just going to improve the model if just for you. It does not do that. Remember, model training and fine tuning is a massively expensive task. So there's a lot of reasons why this doesn't happen, but privacy number one, but cost is also another reason. And finally, your fine tune. If you do choose to fine tune a model in Azure OpenAI service, those models are exclusively yours. The model checkpoints and model fine tuning information that you make available is only available to you. So those are really, really important foundational, fundamental principles that you've got to keep in mind when using Azure OpenAI service. So let's get started and doing some demos.